about this game is that it's too easy. I'm sure the next speaker would have heard this quote before creating his own game. Good evening, ladies and gentlemen. It gives me an immense pleasure to introduce you all to Minh. The creator of one of the most played first-person shooter game, Counter-Strike. The game that doesn't allow you to sleep. The game that pumps in you the team spirit. And the game that messed up my 10th class grades. Minh, more popular by his online nickname Guzman, is a game programmer, a modeler, and a designer. He started working on his first game mod, Navy SEALs, while he was studying his computer science degree from Simon Fraser University in Canada. After tapping all good resources from Navy SEALs, the Half-Life was the most logical choice. That's what he says. All of us have hobbies, right? But making it a career? It requires something beyond just guts. We all make choices, but at the end, our choices make us all. For Minh, turning his hobby into a real career was the biggest move of his life. While working with Valve, he became self-conscious of his abilities, his leadership qualities, and his skills. Working for tomorrow is not a one-day deal because tomorrow keeps coming. And so, Minh decided to work on a game he always wanted to create, the one with active civilians, the one with human shields, the one where dogs attack, the one where you drive cars and whatnot. And so, he finally launched Tactical Intervention on 28th March this year itself. To know more about this gentleman, let's welcome him here with a huge round of applause.
Thank you. Thank you, guys, everyone. It's a great pleasure to be here today. I want to thank the Techniche, IIT Techniche, for inviting me. When they first contacted me, I had no idea how large this was going to be, so I feel a bit nervous right now, so I apologize if my presentation is a bit stuttering. So anyways, I'm going to begin, and it's a pretty short presentation, and at the end of it, if you guys have any questions, please feel free to ask, and I'd be happy to answer them. So without further ado, let me begin the presentation. I've been developing games for over 15 years now, and it's something that I've really enjoyed doing for the past 15 years of my life. And today's presentation is just really going to cover what the process of game development is like, and I hope it's enlightening for a lot of you, as I imagine some of you guys in this room are really aspiring to become game developers, and I hope this will inspire you to look into this as a career. So before I discuss the topic of game development, I'd like to just talk a little bit about my childhood. As a kid growing up, I'm very much like many of the boys in this auditorium. I enjoyed watching action movies like Bruce Lee movies and Rambo and all these types of movies, because for me, I love action movies because they give me a sense of excitement and tension. And this is something that really applies to the games that I enjoy playing, and also the games that I enjoy making as well. So I started playing games when I was 8 years old, back in 1988, I guess it was. But my dad, he bought me a old computer system called a VIC-20. And I don't think anyone in this room even knows what a VIC-20 is, but it's an extremely primitive computer system. And as you can sort of see, the graphics over here for the VIC-20, the graphics were really primitive by today's standards. But the one thing that I remember about those games were they were extremely fun, regardless of how poor the graphics were. So as I grew older, I was able. My parents always bought me the latest computer systems because my dad was a computer freak, and he always loved buying the latest hardware. So I was able to play a lot of the latest games over the course of the past 20 years of my life. And as you can see, the game's graphics got progressively better and better and better. So One of the games that really changed my life and changed the life of a lot of people in the game industry was this particular game right here. This game is called Doom, and it was released in about 1997. And I'm not sure if any of you people here have played Doom, but this particular game really changed the game industry because this was the very first-person shooter. And before Doom came out, there was no concept of playing games in a first person. And when Doom came out, it became such a huge hit that it really changed the way the game industry evolved. And after Doom was released, a lot of game companies started making more and more first-person shooters, and it started to become one of the most popular genres today. And it's still very popular by today's standards as well. So after Doom, I played games like Quake and Half-Life, and eventually played Half-Life 2. And it wasn't until 1997 where I started actually to experiment with creating games, because up until then I was only just a game player, just like many of you people in the audience here. So I never understood the difficulty of making a game. I always felt that it was a really challenging thing, and I felt that it was something that I could never really learn on my own. So when Doom was released, the creators of Doom released a level editor which allowed people like myself and even people like yourself to just amateur people to just create a level for Doom. And even though it was a very complicated process, it was something people can really achieve with a limited amount of learning. So I remember it took me around 4 months to learn how to create my first level for Doom. And even though it was a very long time to learn, it was full of frustration and hardships. I remember the sense of satisfaction I had when I created that level and when I uploaded it to the internet, and I saw people that were playing my level for Doom, and I remember instantly that this is something that I wanted to do for my career, because that sense of accomplishment and that sense of seeing other people play your creation is something that is a feeling that really drives me even to this day. So yeah, that was my first foray into game creation. So now I'd like to just talk about Counter-Strike and how that all began. It began back in 1999 when I was a second-year university student at my college. I was studying to be a computer science programmer, much like a lot of people in this room. And I wasn't really interested in the courses for what I was studying. I was actually kind of bored of them, and I actually spent most of my time playing games, much like a lot of the people in the audience here. So yeah. So I mean, it's okay to play some games, but as long as you try to do your homework, I guess that's something that I hope you guys remember. So while I was in school, I was playing a lot of games, but at the same time, I wanted to create a new game. At the time, there was no other game kind of like Counter-Strike, and I felt that this game could really have an impact in the industry. So I started developing Counter-Strike in 1999, and it took me 1.5 years to create the very first version of Counter-Strike. And when I first released it, it wasn't a huge hit, but it had a pretty big audience, and having that huge audience really motivated me to create more and more versions. So after that, it took me another 2 months to create the next version, and we eventually created 8 more versions like every 2 months. And this sort of pattern allowed Counter-Strike to grow progressively. And as we released more and more versions, more and more people started to play it. And eventually, I think in 2001, it became one of the most popular games in the world. And I was really just proud of that fact. So thank you. So I mean, seeing Counter-Strike being played today by people like yourselves, and like it's been 12 years since its release, it's really quite amazing for me to see, and it's something that I'm really humbled by. So anyways, getting back to 2001, I was approached by a company called Valve, and Valve are the very big company, which I'm sure a lot of you people are familiar with, but they made Half-Life and Team Fortress and a lot of other great things, which includes also Steam, which I imagine some of you use right now. So Valve approached me, and they wanted to make Counter-Strike a AAA title game. And at the time, I was 20 years old or 21 years old, and I had a huge debt from because I was a student, so I had to take out a lot of loans. So I instantly said, yeah, sure, let's work together, you know, and they paid me some money, and I paid off my loans, and so they eventually took the Counter-Strike franchise, and they turned it into a huge phenomenon that we see today. So yeah, that was something that I'm fortunate to have happened. So when I designed Counter-Strike, there was a few design principles that I wanted to focus on that would separate Counter-Strike from the other games and would really make it appealing. So one of the things that I really was interested in at the time was the concept of counterterrorism and how certain countries fight terrorism. So I felt I wanted to make a game that dealt with this particular theme, and I really focused on Counter-Strike to have that element of counter-terrorists. And I think this is one of the reasons why it's so appealing to so many people in the world, because I think this particular theme is very appealing, and it's sort of it's very exciting for a lot of people like yourselves. Another theme, another design principle that I felt was really important to Counter-Strike was it needed to be I wanted it to be a round-based game, and what this meant was when you died, you couldn't respawn right away. So this was actually quite different than other games at the time, where if you died, you instantly respawn and then you can go fight again. But I didn't really like that, because what that did was it didn't give you any value to your player. So by having a system where if you died, you had to wait out to the next round, it gave the player a sense of a fear, because they don't want to die so much. So now they're playing cautiously, and it gives a bit more value to their lives. And I feel that's a really important aspect to Counter-Strike, and I think that's. Oh, okay. Yeah. So yeah, I think that's one of the reasons why I think you guys find it so appealing. It's that fear of dying that's really embedded in Counter-Strike. And so another principle that I wanted to introduce was the concept of weapon progression. When you first start a level in Counter-Strike, you start with the basic gun, and as you accumulate points, you're able to purchase more and more guns, better guns. So this type of system gave Counter-Strike a sense of strategy, and that the players had to worry about. So a good team had to worry about what kind of weapons that they needed to buy in order to maximize their effectiveness. So it's kind of like adding another layer to the gameplay. So I felt that this added a sense of depth to it. And lastly, I wanted Counter-Strike to focus more on teamwork as opposed to just individual skill. Other games out there at the time were Quake and Unreal Tournament, and these types of games, they just focus on players' individual skill and their individual reflexes, which I think is a pretty nice thing to focus on. But I wanted something a bit deeper. I wanted to bond with my players, with my teammates, and I felt with Counter-Strike, I wanted to encourage more teamwork, and whenever I win with my team, it's a much more satisfying feeling than winning by myself. So I think that's one of the key concepts. Thanks. Yeah, I think that's one of the key concepts of Counter-Strike's appeal, and why it's still lasting to today. So with regards to the weapon design in Counter-Strike, when I designed Counter-Strike, I wanted the guns to each have a very specific role. Like each of the guns were very particular to the style of gameplay that a player wanted to play. So, for example, the pistol is a backup gun, which is not really useful in a lot of circumstances. It's sort of a gun that you use when you run out of bullets on your primary gun. So that's it's like a last resort type of weapon. The submachine gun is one of my favorite types of weapons because it had a very low recoil, but it had good power. So the submachine gun was a gun that catered to players that like to run around and shoot. So that's kind of my style. I'm a kind of an impatient player, so I like to just run and shoot. So this is the type of gun that I preferred to use most of the time. The assault rifle was a very challenging gun to master. I think a lot of the very good Counter-Strike players prefer to use the assault rifle. But a lot of the newer players who play Counter-Strike, they find the assault rifle to be a very difficult weapon to use. So it takes a lot of practice to perfect that gun. But I think once you do perfect the assault rifle, it becomes one of the most effective guns to use in the game. So next up, we have the shotgun, which is a very specialized gun, and it's only really effective in close quarters. So I found that the shotgun was only effective in certain maps that really had small rooms and that sort of thing. So it was kind of limited in its role. The sniper rifle was a particular gun that I feel was very overpowered in Counter-Strike because a lot of the maps in Counter-Strike were quite large, and what would happen in Counter-Strike was the entire team would buy a sniper rifle, and then the other team would have a hard time moving forward, and it would cause this very bad gameplay because it would encourage camping, and that's kind of something that I didn't really like about Counter-Strike was when the other team had nothing but sniper rifles and my team had nothing but pistols. It was very frustrating to play against them. So, in my new game, Tactical Intervention, what I did was I limited the number of people who can have a sniper rifle. And what this does is it just basically controls the way the gameplay unfolds. So you don't have as much camping in Tactical Intervention. So lastly, the machine gun, it was just a very cumbersome rifle. It had a really high power, high rate of fire. It was really only useful for situations where you wanted to have suppressing fire to the enemy, because the accuracy on that gun was so bad that it was a very specialized gun that was only had its use as a support role. So now I want to talk about how I programmed Counter-Strike. So all of the code for Counter-Strike was written in a language called C++. So when I created Counter-Strike, I had to program the behavior for the weapons. So whenever the player shot, I had to program how the player's movement would kick up and then kick down. That's the weapon recoil. I also had to program the behavior when a bullet hits a wall. I had to have the bullet penetrate that wall, and also different walls had different penetration values. So for example, if you shot a wooden wall, it would penetrate very thick wood, but if you shot a metal wall, it can only penetrate very thin metal. So these types of characteristics are something that I had to program into Counter-Strike. Also, I had to program the artificial intelligence for the hostages. When you grab a hostage and you run back to the zone, I had to program how he would follow you and that sort of stuff. And lastly, I programmed the gameplay rules for the various different game modes, like bombing mode and hostage rescue. So I just basically had to program the various conditions that had to occur before a team can win a particular mode. So yeah, if you look at all the code for Counter-Strike, it's not a whole lot. It's actually fairly minimal. And I think I spent maybe 6 months just programming Counter-Strike. I think most of the time I spent on Counter-Strike was actually creating the graphics for Counter-Strike. That was the most time-consuming part. So because I built Counter-Strike on top of an existing game called the Half-Life game, I actually didn't have to program a lot of the features that already existed in that engine. So, for example, the Half-Life engine was responsible for doing a lot of things, such as rendering the graphics, the 3D models that you see in the game, and also the sprites, that all those other flashy, cool color things. That was all handled by the engine, so I didn't have to program any of that. Also, the sound effects engine, whenever I wanted to play a sound in a particular area, that was all handled by the engine. Character movement was also handled as well. And also collision detection, when two characters would run into each other, the engine would determine whether or not they would collide with each other. That was actually a very simple process. The way that they did that was actually, they just, I don't know if you can see. Yeah, so you can see these two characters here. And the way collision detection works for a character is, it's pretty simple. What they do is they basically create a box, a rectangular box around that character. And whenever those two boxes collide, then that gets detected as a collision. So it's a pretty simple mathematical formula to detect collisions by using this particular system. But when it comes to shooting other players, we had to use something a bit more advanced. We had to actually surround each of the players' limbs with separate boxes. So as you can sort of see in this picture here, these red and blue boxes represent the various, we call them hit boxes for the various limbs of the player. So it was a much more accurate way of representing shooting at a player, because if you shot a player between his legs here, the bullet wouldn't hit the player. It would just go through the legs. So having this system allowed for more accurate bullet detection between shooting players. So lastly, the Half-Life engine was responsible for the networking of all the entities in the game. So this is a really important part of multiplayer games, because the Half-Life engine had a very robust networking system that is based on a client-server architecture. So I'm sure a lot of you are familiar with the two different architectures for networking. There's two main architectures. One of them is called peer-to-peer, and one of them is called client-server. Peer-to-peer is a very kind of an older system, and it's not really good for first-person shooters. And it's not really good for systems that have more than 4 players. But since Counter-Strike has 32 players, we had to resort to a client-server system. So basically, the client is responsible for handling the input from the keyboard and the mouse. So whenever the player would press certain buttons on the keyboard, he would send that input up to the server, and then the server would use that input and determine where the player would be in the world. So by having this system, it allowed the server to have a lot of authority over the game, and it kind of prevented cheats from being made by having this system. So now I want to talk about how I created the 3D models for Counter-Strike, and also the 2D graphics as well. I used a program called 3D Studios Max, and it's a very popular program that a lot of game studios use these days. And for the 2D textures, I used Photoshop, which is also, I'm sure many of you have heard of. So these two programs are the main tools that I use to create graphics for Counter-Strike. So here I like to explain how I create an object in a game. So before I create an object, I really want to take as many photographs of that object from as many angles as I can, because this will help me get a sense of the proportions of the object, and also just a sense of scale on how the object should look. Another advantage of using photographs for objects is it allows me to create a texture map for the object. So what you see here in the middle is actually a texture of the object. And what I do is I use that texture and I apply it to the 3D model here. And it looks very similar to what the actual object looks like. So by using photographs to create the texture map, it saves me a great deal of time. And it also allows me to create a very authentic looking object. So as you can sort of see, the finished product looks quite real. And it's, I think it took me maybe 1 day to create this object from scratch. So one day, I just took all the images and created texture and the 3D model in about 1 day. So it's a great time saver when you can take photographs of your object. Regarding the character creation system, it's basically the same as what I just discussed before. I try to take as many photos of the character from different angles. Obviously, because I'm modeling the character in the 3D, I need to know what he looks like from behind as well. So when I'm creating a character for a 3D game, I'm actually, I'm limited in the amount of polygons that I can use, because these days 3D engines are only capable of rendering so many polygons. So I have to be careful of how many polygons that I use for my characters. One of the key things to do when I'm creating a character is I spend a lot of polygons in the area where the character is bending. Because when the character is animating, the areas where they get bent get deformed a lot. So if I don't have enough polygons in those areas tend to look really sharp and unnatural looking. So as you can sort of see in this character over here, you can sort of see there's a great deal of polygons around his elbows and around his knees. These are the typical areas that get deformed a lot during a character's animation. With regards to the weapon modeling, it's very similar to the characters. I grab as much reference photos as I can, and I model the weapon as accurately as I can, because when I'm animating the gun, actually, the gun is animating, so I need to create the model to be as accurate as possible. So I actually have to model the insides of the gun. So as you can sort of see here, I modeled the bullet with inside of the magazine. And also the ejection port gets modeled as well, because when the gun is shot, the ejection port is animating, so the player is he's able to see the inside of the gun. So it's a very, very accurate model of the gun, and yeah. So the next step of creating content is the animation step, and this is a very for me, it's one of my favorite steps, and but it's also one of the most difficult steps, and it's the way we animate characters in games is we use a system called Skeletal Animation. So what Skeletal Animation is what we do is we take the 3D model, like before over here. So this is the 3D model. We call this the 3D mesh. So we take that 3D mesh and then we rig it. We call rigging it. So we rig it to a bone system, a skeletal system. So the skeletal system is basically just the bones, like what we have in our bodies. And the bones just basically drive how the 3D mesh will deform. So as you can sort of see in this particular pose here, as the bones are positioned in a certain way, the 3D mesh, which is represented by the gray object, gets deformed with the bones. So this is called skeletal animation, and this is something that all games, all movies, a system that is used in all 3D animation. So because there's so many bones in this particular character, I believe there's like 16 bones, it's very tedious for me as an animator. I don't really like to position all, like I don't really want to move every single bone. It's very tedious to do that. So what we have set up is a system where we have controllers, and what the controllers do is they actually drive a set of bones. So for example, this controller you see here at the foot, when I move that controller over here, the entire foot will actually move with it. So you'll have the thigh, the calf, and also the foot kind of follow the place where I move the controller. So this is called inverse kinematics, and it's a very useful system of just being able to position your character in a very efficient way. Instead of manipulating every single bone, we just manipulate one particular controller. And yeah, that's a very common system that animators use, inverse kinematics. So an animation is basically a series of frames. When I create an animation, I don't actually create every single frame in that animation. So for example, this animation is a 25-frame animation. And when I create the animation, I'm only creating keyframes at very specific points in the animation. And these keyframes represent the major, basically, poses of that animation. So for this particular animation, it's an animation of the player kicking. And as you can sort of see, it only contains 6 keyframes, but it's actually 25 frames long. So what happens is when I create the keyframes, the software that I'm using, 3D Studios, it does what's called an interpolation. It will actually create frames 2, 3, 4 between frames 1 and 5 by just interpolating between it. You can sort of think of it as kind of like filling in between 2 points. And it's a pretty simple mathematical concept. So imagine if I'm here on frame 1, and then I move to here on frame 2. Oh, I'm sorry, on frame 5. The computer, or the software generates frames 2, 3, 4 based on an algorithm, an interpolation algorithm. And it's a pretty simple math. It just, I'm pretty sure you guys can imagine how it works. But it's called interpolation, and it's a very useful way of just saving a lot of time, because I think 10 years ago, we used to, as an animator, I used to have to create every single frame. Like I would have to create all 25 frames. So you can imagine how much time I'm saving now by having the system of interpolation, because it cuts down my workload by a factor of 5. So getting back to how we, before I talked about how a 3D mesh is rigged to a skeleton system, and this particular slide kind of illustrates how that happens. So in this area here, you see the player's calf bone, and you see his foot bone. And the white lines represent the 3D mesh of the player. So the 3D mesh is composed of a series of vertices. So what happens when I rig a 3D mesh to a bone system is I basically take each vertex, and then I assign it to a particular bone. So you'll see here in this picture here, I basically took all the bones that represent the calf, and I just assigned it to this particular bone here. And for the vertices that represent the foot, I assigned it to the foot bone. So when I animate, so when the bones move, the vertices that get assigned to it move with it. So this is called skeletal animation, and so you can sort of see the importance of proper rigging. If you don't rig the bones, if you don't rig the 3D mesh properly, you get a very unnatural movement of the mesh. So as you see in this area, it's a very unnatural bending of his elbow, so it's almost cartoonish. So it's really important to properly rig the 3D mesh properly, so it looks like it's a very natural bending, as you can see in this image here. So next, I'm going to talk about how we design levels for games. The first thing I do when I create a level is I like to draw the level on a piece of paper, and this gives me a sense of layout for how the level is going to look and how the players are going to flow. This is a really important step for when I'm creating levels, because if I don't get this step right, and if I spend too little time on this step and ignore it, later on I'm going to make a lot of mistakes when I'm creating the level. So it's really important to get my sketch layout done properly. So I tend to spend a lot of time making sure that this looks proper, and And one of the key things to do when I'm creating a layout is I like to draw like how I draw where the each team will start, and then I basically try to imagine where each of the teams will go during the gameplay. So being able to visualize this flow of player movement will allow me to create the level, so it's more fun and more so it's just more enjoyable to play with. So okay, thanks. yeah. Yeah, so once I'm happy with the layout, I move on to the blocking out phase of creating the level. So inside the level designer, the tool that I use, it's called Hammer. So inside that tool, I create very primitive shapes to represent the level. So basically just very simple walls and simple flooring. So it helps me to get a visual sense of 3D of how the level is going to look like. And once I'm happy with that stage of the, I can just apply some textures to the level. And at this stage, I'm able to get a good sense of how the coloring will look and how the final layout will look. And finally, when I'm happy with that, I add the details and the lighting up to the level. So now, as you can sort of see, it looks like a very finished level, and it looks much more realistic. So it's really important to get the lighting done very well, because I think lighting is a very important part of to the look of the level, and lighting plays a very important part in creating a sense of mood. And so I spend a lot of time trying to get the right lighting of the level. And so one of the key things about Counter-Strike was when we were creating Counter-Strike, one of the design principles that we told all of our level designers was don't make your levels too dark, because players don't like playing in dark levels. So we had a very strict set of rules. You have to make the level a certain set of brightness. So that's why you see in Counter-Strike there's not very many dark levels. So it was a gameplay issue, because a lot of players hated fighting in the dark. It was kind of a very frustrating exercise. So yeah, Counter-Strike levels were very bright. So that is pretty much the conclusion of this presentation. And so to conclude with, game development is a very time-consuming process, but it involves a lot of different responsibilities, from creating graphics, creating sound effects, to programming. And it's really important that when you create a game, you really want to work with people who have a very similar vision to you, who understand what the final product should look like. Because I've worked on games in the past where I've worked with people who don't really understand or don't really agree with what the final vision is going to look like. And it's a very frustrating process, as many of you can imagine. I mean, I'm sure you guys have worked in group projects where some of your team members were just like completely slacking off or just not agreeing with you, and you wanted to like kick them out or something like that. So yeah, it's really important that when you work on projects of this kind of scope, of any kind of scope, is that you really have to communicate with your team members, and you really want to make sure everybody's on the same page. So yeah, it's important that occurs. So once you actually finish the game, and once you release the game to the public, another thing that you really want to do is you want to listen to the public's, the players, and how they're reacting to your game. So it's really important to listen to their feedback and to try to understand how they play the game. Because when you work on a game for so long, you become numb, and you almost don't even see the faults of your own game, because it's almost like being married for so long. Like you just don't even realize how stupid this person is. But it's almost like, well, I'm not saying all marriages are like that. I'm just saying, like in a relationship or in things, when you become too accustomed to a certain thing, you become almost blind to their faults. So it's really important that when you release the game to the people who've never played it before, you really want to listen to what they're saying, and really want to understand why they like the game, why they don't like the game, because that's really the critical part about making your game a success, is to listening to player feedback. So secondly, another key part about making the game a success is you want to get your community involved in your game. So one of the things about Counter-Strike was we did really well was we allowed our community to make levels. We allowed them to make new content for our game. And what this did was it increased the longevity of our game. So people, even to this day, are creating new levels for Counter-Strike. And this is the main reason why it's still so popular. So yeah, having a community interaction with your audience is one of the most important parts about a game's success. So now I guess I imagine a lot of you guys are very interested in making games, or maybe some of you guys aren't. But if you are interested in making games, it's challenging. It's very time consuming, but it's not impossible. And I really want to stress that, because Before I started making games, I always had it in my mind that, making games was something that only really, really smart people can do. But, the truth is, it's not, because I'm not really that smart. And hey, no, you don't supposed to applause that one. No, I'm just kidding. Anyways, the thing that I'm trying to say is that each and every one of you have the potential to do anything that you really, really want to. The only thing is whether or not you want to commit that time. And if you're willing to commit the time, if you really have the passion to make games, then by all means do it. And don't worry if you think, oh, I'm not going to be able to get it done. It's impossible. It's not impossible. It only takes like 20 years. No, I'm kidding. It only takes maybe 2 years to learn it. So let me just give you hints on what you should be. So suppose you want to make a game and you're wondering where should I start. So I think I really want to recommend something called Unity 3D. Unity 3D right now is one of the most popular game engines in the world. The reason for that is it's free, and because it's free, everyone can download it and just experiment with it. And because it's so popular, you have so many people out there that are using Unity, so it's not hard to find people that are having problems that you might be having during the course of learning how to make a game. So I really recommend downloading this package if you guys are interested in making a game. It's a very, very it's pretty intuitive, and it just has a huge community, and I think that's the most important part of it. So if you want to make graphics, if you want to make 3D models, there's a program called Blender, and this is also free. And because it's free, it has a huge community, and it's also very robust because it's able to do anything that other more expensive software can do. For example, 3D Studios. So I really recommend these two particular packages for people who out there who are really interested in this career. So that concludes my presentation, and I want to thank you guys for listening. Hopefully it wasn't too boring. So if you guys have any questions regarding this topic or anything in particular about life, yeah, feel free to ask. So I think, yeah, I'm pretty much done. So I'll take questions now if you like. Hello. Nice to meet you.
Sir, I started playing Counter-Strike before 1 week or 2 weeks only.
Oh, really?
I'm feeling very bad about that because I couldn't enjoy the game before that. And other thing is, when you see your character in that game, Minh, it's almost different when you compare with other characters. Mm-hmm. Can you tell me what's the different programming is being made for that? Or
so the question was, the characters in Counter-Strike are different.
About your character in CS?
Are different than the characters in other games?
No, sir. Your character in CS.
Oh, my character?
Minh.
In CS. I don't have a character in CS. I'm not sure I understand the question. Sorry, I'm sorry. I'm not quite sure I follow the question. Sorry. Can you repeat it again?
So when I see some other characters in CS and see your character in that, I feel a very different thing in character-wise. Matlab, in reloading, in a way of attacking.
Yeah. Okay. So your question is why do you feel different?
Only your character.
Why do you feel different? I don't know. Did you eat breakfast that day? I don't know. I'm sorry. Yeah, I don't know really. I don't have an answer to that question. It's really complicated question actually. I need to think about that one. Can I email you? I'll email you the answer. Okay, I'll email you. Sorry.
Thank you.
Yeah, I'm sorry. I couldn't answer that one. Yeah. Do we have any other questions? Hopefully easier ones.
Sir. It's on the right.
Oh, hi.
So when you started developing your game, Counter-Strike or any other game, for example, how much time was spent on fleshing out that idea, like the vision of what the game was meant to be, and did it develop as you went along, or did you have a clear sketch at the beginning?
That's a great question. So designing Counter-Strike, I think I didn't spend a lot of time designing it. I spent the way we designed Counter-Strike was I would kind of get a lot of feedback from the players, and they would actually kind of help me decide which direction I wanted to do with the game design. So I used a lot of feedback from players to help with the game design. So I didn't actually spend any time writing documents on game design. It was very organic. I was very kind of like working closely with the community, working closely with the players who were playing it. So that's how I designed Counter-Strike. That was a great question. Yeah.
Hello, sir.
Hi.
Sir, here.
Hi. Where are you? Are you hiding? I can't see you.
On your left. Sir, on your left, sir.
Oh, there you are. Oh, sorry.
Yes,
hi.
Sir, hello, sir. And I just wanted to ask, there's a debate going on that all these games, violence pertains to the, violence in these games pertains to the life of the kids who played. Do you agree, or do you feel that it's just a hypocrisy?
Yeah, I mean, I think it's a bit of a hypothesis because I think people in general are kind of, I think most of the people who play these games and even people who watch violent movies, they understand the difference between reality and fantasy. And I'm pretty confident that all of you people in this room understand the difference between reality and fantasy. So, yeah.
And
generally, when media tries to ask me this question, and they ask me if I am at fault for any of these violent reactions in society, I tend to think that it's a very localized, certain isolated case, and I don't think it applies to the majority of people who do play games. So no, I don't really think that violent media will actually make people more violent. I think maybe, if anything, it kind of highlights their behavior. So I don't know. Yeah, but no, I don't really feel that Counter-Strike promotes violence.
And so one more question.
Except I will tell you one thing, and I do feel guilty about this. There was this one time I read about this story in Taiwan, or it was in some country. These guys were playing Counter-Strike in a LAN, and one of the guys lost in Counter-Strike, and he got really mad, and he got up and he stabbed the other guy. So. So I don't want to laugh about that, but I'm just want to say that was a particular example of someone perhaps indirectly being affected by the game, and I really feel bad about that because I don't want to be responsible for people getting hurt, So I think it's kind of terrible, and I shouldn't have brought that up actually. Sorry. Next question.
And so one more question, sir. Sir. Can a developer create a game that is at the same time exciting and not addictive? I mean, most of us start playing games and after some while we have a regret that we wasted so much of time. There's some addiction related to these games. I mean, can we create a game that is not addictive and exciting?
Yeah, that's... I think if it was not addictive, it wouldn't be exciting. So I think the two have to be together, Yeah. Yeah, but that's a good question.
Hello, sir.
Hi.
Sir, on your left.
Oh, I see you. Hi.
Right. Sorry, I'm sorry.
Yeah. Oh, my
So,
right. Oh, sorry. Sorry.
Sir, I wanted to ask that can you please give us some more information about your current project, Tactical Intervention? Like most of the people over here, they haven't heard about it. Mm-hmm. They don't know about it, and how is it different from Counter-Strike?
Okay. I have it on my machine. Let me try to run it. Let me see if you guys can. I can show you what it looks like in the game. Actually, I don't have a mouse. Can you give me a mouse? Yeah. Actually, let me just see if I can run it. So yeah, one of the key differences in Tactical Intervention is that it has a lot of new features that Counter-Strike doesn't have. So one of the biggest features that we added was the introduction of cars. So on one of our level, we have a car chase, and you have the entire team chasing the other team in cars. So it's really, really exciting, and I think that was one of the most popular levels that we had. And another thing we have in Counter-Strike, we also have dogs, which is really, really cool because you can use the dog as kind of like a teammate, and the dog is he's really smart. Well, he's more smart than some of my teammates, but he's just really... Oh, okay. So anyways, this is basically... Oh, there's sound.
Capture civilians and eliminate the CTs.
Okay, great, yeah. So, yeah, basically Counter-Strike. Let me just get myself a dog here. So I guess the one big thing is the graphics are improved. It looks more realistic than what Counter-Strike looks like, and let me just,
Capture civilians and eliminate the
so
CTs.
as I mentioned before, I have a dog, and the dog is really cool because, yeah, who loves dogs? You guys love dogs. You know, I should have added a cow because I know cows are popular. So this is a particular level of Counter-Strike. One of the key things. Oh my god, it ended so fast. I'm playing with bots, so they're really stupid. Hang on. So one of the key things that I really wanted to work on with this new game, TI, is I wanted to make the environment very interactive and very it reacts to your bullets more. So as you can see, like everything I'm shooting is kind of reacting to my fires, and that really gives the game a sort of a very exciting kind of Hollywood kind of style. Oh my god! So another cool thing is the hostages in Counter-Strike, you can actually, or in TI, you can use them and you can grab them, and like now I use them as a shield, and like if I get yeah, so yeah, that's a really effective tactic to use as a shield. So we have that. So another level, I have it, it's kind of in a really high building, and at the top of this building you can actually rappel from the roof. So this is really fun to do, to surprise your enemy. Let me just show you how that one's done.
Rescue the hostages, or eliminate the terrorists.
So this particular level takes place in a high-rise, and it's really, really tall. And what I can do is, on the roof, I can actually attach myself to one of these points, and now I'm actually rappelling. Yeah. Yes. So it's pretty cool because sometimes if the enemy is not expecting it, you can just jump right in and then surprise him and just really cause havoc. Open the window. So yeah, that's pretty cool. And my dog, he cannot, yeah. He's actually pretty smart. He opens doors, actually. My dog opens doors. It's really cool. Watch this. Oh, come on. Go through that door. Damn it. Okay, hang on. All right, come back. Oh my god, where'd he go? Oh, yeah, oh, what? He was, okay. Yeah. No. Yeah, okay, that was a bug. You weren't supposed to see that one. Sorry, guys. That was embarrassing. Yeah, it's still in beta. There's still a few bugs that we're working on, but you know, we're gonna get to it. We have a really small team working on this game. It's only like 5 guys, and it's pretty hard because mostly a game of this magnitude usually takes around 20 guys. So working with just 5 guys it's a very difficult process because it's taking longer than it should really. So I showed you the dogs. I showed you the rappelling. I have shields. Shields are pretty cool. I mean, this is pretty cool because you can't really shoot with the shield, but it's only useful if you want to protect your teammate. So like I've got a teammate back there. And where are you going? He's going this way. Ah! Stop it! Damn it! Ah! Okay, these bots, they're kind of stupid. I mean, the game is not gonna have bots, so I only use the bots to test them. So. Anyways, the shield is useful because it protects your teammates, and you can also use it to bash the enemy. So if you get up to an enemy, you can bash him. Damn it! Yeah. Okay, sorry. Where did I go? Oh crap! Yeah, you can also throw the shield as well when you're done with it. Yeah. So yeah, that's shields, and I think you guys want to see the cars. So let me just show you the car level. So this is a pretty cool level. Probably one of the most popular levels during our playtest. Everyone seems to enjoy this level. It's very exciting. So I'm driving the car. I'm a passenger. Yeah, hang on. Whoa. Hang on. So, So I'm a passenger in the car, and it's being driven by a bot. And as a passenger, I can actually lean out of the car. So when I lean out of the car, I can actually rotate my view like 360 degrees. So it gives me a lot of freedom to shoot. But obviously, when you lean out of the car, you're much bigger target, so the enemy can kill you much easier. So sometimes it's safer just to sit inside the car and just aim like that. But when you're inside the car, you have a very limited view, so you want to use the leaning feature whenever you can. Another thing you can do is you can actually duck. So sometimes if you're getting shot at, you don't want to get you want to be a smaller target. You can just duck, and that's pretty cool. So if you get out of the car, you can actually carjack another car. Let me just find a car to carjack. Where are you? I'm cheating. I'm cheating. So by the way, you're not gonna fly in the game. I'm just doing this for purposes of. Yeah. Okay. So anyways, so if I see a car on the road, I can tell him to get out of the car, and then I can steal his car. And now I've got my own car, and I'm driving, and it's getting blown up. Yeah. Yeah. So. So that it's pretty exciting mode, and so the objective for this for the terrorists, we're supposed to kill the VIP car. And the counter terrorists are escorting a VIP, and he is in that car. So as a terrorist, I need to. Oh Jesus! Right. Okay, he's running me over. I'm sorry, guys. I'm sorry. I'm better than this. All right, so I'm supposed to kill that. Blow that car up, and I'm just gonna give myself a rocket launcher. Hang on. Oh, where'd he go? Where'd he go? Oh yeah, I win. So now I whoa, there's a helicopter. So once I kill the guy who's carrying the case, I basically take the case, and then my helicopter's gonna come, and I just basically. And I win. I bring it to the helicopter. So that's that one. Yeah. So the game is it's actually released right now. It's actually on Steam. So if any of you guys have Steam, you can just go search for Tactical Intervention, and you can download this game. It's free, and you can just play it right now actually. So hopefully you guys can check it out later on. So yeah, that's pretty much TI. Yeah. Thank you. Thanks. I'm glad you enjoy it. Yeah. So yeah, I mean, if there's any more questions, please feel free to continue.
Hello, sir. Sir.
Oh, hi.
Sir, yeah, on your left. Sir, on your left.
Oh, sorry. Yeah. Yeah.
Sir, I wanted to ask you if you have anything special coming up for the motion sensing feature of Xbox One.
Oh, Xbox One. Right now, there's no plans to release our game on Xbox One. It really depends on how successful Tactical Intervention is. If it becomes a very successful game, then possibly we can work with another company to help us bring it to Xbox. But right now, this game is only for the PC, and that's the only plans we have.
So you have any plans for including the motion sensing features?
motion sensor.
Yes, sir.
Oh, you mean like Kinect and those things?
Yes, sir, Connect.
No, we don't. Because I don't think that stuff really. I don't think it's really good for first-person shooters, especially competitive first-person shooters. Because right now, a lot of the motion sensor stuff, it's not very fast. It's kind of slow. So when you move, the response you get is actually kind of delayed. So it's very difficult to play an FPS game with something that has delayed movements. So it's not something that I'm looking into at the moment for tactical intervention.
Okay, sir. Thank you, sir.
You're welcome. So many loopholes. There's so many areas where the hacker can actually get in there and change the game that it's impossible for us as a game developer to cover up all those loopholes. So in order to do that, we would have to make a game that's so very, very 100% secure, but it would also be very slow. It would be very slow for the actual players who play the game. So it wouldn't be a very fun game. So in terms of how do we combat the cheats for a game like Counter-Strike, what we do is we detect the cheats. So we have to have an ongoing team of cheat detectors. Basically what they do is they detect all the latest cheats that are released. And if you detect the cheat, the most you can do is just ban the player who did the cheat. And that's really the best thing that we can do right now, unfortunately.
Okay. Thank you, sir.
You're welcome. Yeah.
Excuse me? Yeah.
Hi. Yeah, sorry.
We just started developing games in Unity, and we already made a couple of them. So we would like to ask how we go about after the post-game development phase about the advertising and publications.
Mm-hmm. Oh, so you develop your game and you wanna do some advertising and marketing? Is that the question? Yeah, that's a good question, and it's really important because getting your game exposed is probably the hardest step of. Well, it's not really the hardest step, but it's a really hard step, and it's really important that you work with a advertising group, like a promotion group, someone who has experience getting exposure for games. It's very difficult to do it on your own. If you really wanted to do it, though, maybe you might want to look into Facebook, like Facebook and Twitter and these types of tools. But I think the best thing for you to do is to get your game tested with players, and if a lot of players enjoy the game, then maybe you can bring the game. Maybe you can work with a advertising company and use them to get more exposure. So that's really the only way to get your game exposed. So. Yeah, it's a good question, though.
Thank you.
You're welcome.
Hello, sir.
Hi.
Sir, in middle.
Yes. It's like a game.
Sir,
it's
this
like
way.
Waldo.
Okay.
What? Oh,
hello, sir.
Hi.
Sir, I am Parikshit.
Hello.
So I want to ask you two questions. So one is, apart from C++ programming language, what are the other languages you have used to develop the first version?
Just for Counter-Strike, I just use C++. But for other game engines, like the Unity engine and various other engines, they use C# or Java. So those three languages are probably the most common ones that you'll see. C# and Java and C++. But
okay, sir, next. Sir, how much you earned from the first version of your Counter-Strike?
Sorry, I didn't get that, but thank you. It sounded nice. Okay.
Thank you, sir.
You're welcome. Thanks.
Sir.
Oh, okay.
Hello.
Hi.
Sir.
Hello.
Sir, I want to ask, sir, your new part of the game Counter-Strike Global Offensive. What do you want to say about it?
Sorry, can you repeat that again?
Sir, you just released a new part of Counter-Strike Global Offensive. Sir, what is new about it?
I had no role in that game, actually. That game was completely made by the company I used to work with. They're called Valve, and I didn't work on. I left Valve about 7 years ago, so I had no role in CS:GO.
Yeah. Okay.
You're welcome. Yeah.
Hello, sir.
Hi.
Myself, Kunal. Sir, is the creator the best player in this game, or you usually play with using cheats?
Am I using cheats? No, I'm not using cheats when I play. Well, not all the time, but I'm not that good at the game. I'll be honest with you. You know, the game is very. It requires a lot of skill. It requires a lot of practice. So I just don't have time to really play the game as much as I would like. But I mean, back when I was playing 7 years ago, I used to be very good. I used to be maybe top 10 in the world or something.
Sir. Excuse me, sir. So, do you support using cheats in game, or you support using it in a natural way?
No, I don't support cheats at all. I think it's unfair. It's just not. It's not fun, and I really don't like hacks. Yeah, for sure. No. Yeah. Yeah. Thanks. That was a good question. Yeah. Okay. Yeah. So. Okay, so anyways, I think that concludes our time, and I want to thank you guys for coming out, and I hope you enjoyed it. So, thank you. Okay, all right, awesome. So thank you. I want to thank Techniche again, or IIT, for inviting me out here. It was an awesome experience for me, and it was really great to see you guys, because when I see you guys are so excited and so young. You remind me of myself when I was 12. When I was your age. 12 years ago, I was your age. Trust me. And I was really excited, and I really wanted to get into the world and start my career. And I kind of see that in you guys right now. And I want to wish you good luck in your career, because it's going to be a lot of challenges that you guys are going to face, but if you have the drive, if you have the passion, you guys can achieve anything you can, because look at me, I'm nothing. I really am. I'm not that smart. You know, trust me. I'm just like you guys. I just had a lot of time on my hands. That's all. Yeah. So thanks again, guys. Yeah. Okay. Thank you.
Thank you, sir, for your encouraging words. I loved it. I'm sure the spectators loved it too. Now we have another game to get addicted to. Now I would request Mr. Rahul Vinod Uputuri, Vice President, Student Gymkhana, to come on stage and felicitate Mr. Minh.